Hi everyone, this is Mrs. Chirigno, and this is the last page of the Algebra 1B Semester 2 exam review. This covers Chapter 11, so this is the stuff that we were doing the most recently. Question 36 is asking us to factor this expression. So what I would start by looking for here is a greatest common factor. So I want to look for the biggest thing I can find that goes into 36, 60, and 84. What you're going to have to be really careful with here is there are a lot of things that go into all three of those numbers, but you need to make sure that you find the biggest. So if you have to break down and use a factor tree to find all those factors, go ahead and do it because you want to make sure that you're not missing something. The biggest number that goes into all three of these is actually 12. Okay, so if you got 6 or you got 4 or something like that, you didn't get quite big enough. And then let's look at our x's. This one has 5 x's, this one has 9, and this one has 10. So the most I could take from everybody is this 5, because I can't take any more than what the smallest one has. And then here I have 8 y's, I have 5 y's, and I have 7 y's. So my smallest number is right here, y to the 5th. That means I can take 5 y's from everything. So that's my GCF right there. Now I have to find what would be left over inside the parentheses, which means I want to think about if I were to multiply this back together, how could I make it form my original expression? So 12 times what would give me 36? That would be 3. And then this one had 5 x's, and I'm taking 5 x's out, so there's not going to be any x's left. This one had 8 y's, and I took 5, so I'll have 3 of those remaining. Plus, that came from here. 12 times what makes 60? You could check that in a calculator if you weren't sure, but the answer is 5. And then if I take 5 x's and this had 9, I would have 4 left. And I'm taking 5 y's and this one had 5 y's, so I won't have any y's left there. And then 12 times what makes 84? That would be 7. And if I take 5 x's from 10, I would have 5 remaining. And I'm taking 5 y's from 7, so I would have 2 remaining. Okay. Now, this did form a trinomial in here, but it didn't form one of the trinomials that's in the form that we know how to factor. So this is just it. This is just your final answer. You pulled out this GCF, and this is what's left over, and you have factored completely. Okay, let's take a look at 37. Another one asking us to factor completely. So the first thing, again, that I would look for is a greatest common factor. So I've got 5, 25, and 30, and you want to think about what's the biggest thing that would go into all three of those. The biggest thing that goes into all three of those is just 5. And then this one has 3 m's, this has 2, and this has 1. So that means that I could take 1 m from everything, because the smallest number of m's is just that 1. So my first term, if I took 5 off of the 5, that would just leave me with a 1. And then I take 1 m off, so that's going to leave me with 2 m's, m squared. 5 times what would give me 25? Well, 5 times 5. And then I'm taking 1 m off of that, which leaves me with just 1 m. Minus, and then 5 times 6 leaves me with 30. And then I took that m off, so that's all I'm left with. Now this time, this is a little different than the last one, because this trinomial I can probably factor, because this is in that form, the x squared plus the something x plus the something. So I'm going to leave my 5m here. And then I'm going to set up 2 parentheses. Now don't let it bother you that these are m's and not x's. It still works the same way. Okay? So I'm going to put an m here and an m here. Now this means that I want to multiply to make a negative number. The only way you can multiply to make a negative number is with 1 positive and 1 negative. And now I need to think about what would multiply to make 6 and add to make 5. Now you're going to have to be really careful with this one, because I see a place that you could make a major error. Let's think about all the ways we could multiply to make 6. There's really not too many. We could do 1 times 6 and we could do 2 times 3. Now, this one probably jumps out at you right away, because 2 plus 3 gives you 5. But remember that you're going to have 1 positive and 1 negative. So if you had a -2 or a -3, that's not going to give you 5. Okay? This one's really going to be more like subtraction because you're adding a positive and a negative together. So 1 and 6, those would be able to make 5 if you had one of them be negative. And we want it to be a positive 5, so that means I would like to have a positive 6 and a negative 1. And please, please, please double check your work here. So 6 times negative 1 does give you negative 6, and 6 plus negative 1 gives you positive 5. So check by multiplying and adding those numbers together. And then this whole thing is your final expression, 5m times m plus 6 times m minus 1. Okay, let's look at 38. This is another one that's asking us to factor, and hopefully these numbers are jumping off the page at you. Think about what's special about 144 and 25. Those are both perfect squares. So I can factor with that, the trick that we talked about, where we have 1 plus and 1 minus, and we're really just taking the square root of both terms. So the square root of 144 is 12, and then c squared, if I split that in two, I would get c and c. So I'm going to have 12c and 12c. 1 plus and 1 minus, because that's your rule for difference of two squares. And then the square root of 25 is 5. So 12c plus 5, 12c minus 5. Maybe write that a little bit nicer. 12c plus 5, 12c minus 5. And that's as far as you can go with that one. So that would be your factored version of that perfect square. Okay, 39. It's giving you a polynomial here, and it wants you to state the degree, the number of terms, and the leading coefficient. Whoops, went too far. Okay, the nice thing is this one's already in standard form for you, and I know that because I see that these exponents are written in descending order. So we went from 4 to 2 to 0. So the degree is just the highest exponent there. So my degree there would be 4. My number of terms is 1, 2, 3. And then the leading coefficient is just this coefficient up in front. Again, you do need to check to make sure you're in standard form before you find that leading coefficient. But this one already is, so I can just go with that 3 as my leading coefficient. And that's it for that one. Okay, last question. A box is folded from a sheet of cardboard 20 by 30 inches by cutting the squares out of the corner. So hopefully this is starting to sound familiar to you. We've done ones like this several times now. So here's my sheet of cardboard. Ignore that tail there. And it's 20 inches here and 30 inches here. But I'm going to cut out corners here and here and here and here. So really these corners are gone now. I have a good way, since I'm not using pencil, to show that, but I'm cutting these off. And then I'm going to fold here and here and here and here. And hopefully you can visualize that that would form a box. And I want the volume of the box. Well, first you're going to have to know how to find volume of a box. Easiest way to do volume is length times width times height. Okay? So I want you to picture this box all folded up. The length of the box would be from here to here after I cut off those corners. So this used to be 30 inches, but then I cut off an X here, and I cut off an X here. So really what I'm left with here is what used to be 30 inches, and I'm taking 2x off of that. So my length is 30 minus 2x. My width is going to be similar. It used to be 20 inches from here to here, but I cut off an x here and I cut off an x here. Cut off all these x's. So this side here, and I guess I'll just write it over here, is 20, and I cut off 2 x's. So my width is 20 minus 2x. And the height of the box is a little bit tougher to visualize, but if you picture folding these flaps up, the height of the box is just the length of one of these flaps. And if you think about it, it's this distance here, which was just x. So the height of my box is just x. So this is what my expression is going to look like. 30 minus 2x times 20 minus 2x times just x. Well, I would start by foiling those first two together. So 30 times 20 is going to give me 600. 30 times negative 2x is negative 60x. Negative 2x times 20 is negative 40x. And negative 2x times negative 2x is positive 4x squared. And do keep in mind we still have this lonely x down here at the end. Before I mess with that x, I'm going to put together my like terms here. So I'm going to say that my volume is 600. Negative 60 minus 40, or you could think of this as negative 60 plus negative 40. Either way, it gives you negative 100x, and then plus 4x squared. Still have my lonely x down there. And now, if I want to multiply everything through by this x, and I do have to distribute this x to everything, my final volume, and I squeeze it in over here, is going to be 600x minus 100x squared plus 4x cubed. And that would be my final expression right there. Okay, that is it. We have finished the entire exam review. Best of luck to you next week.